So what we have are three different pictures of substances undergoing some type of change. And what we're going to focus on in this video is classifying things as either being physical changes or chemical changes. And you might have already thought about this or seen this in a previous science class. But when we talk about a physical change, we're talking about where there could be a change in properties, but we're not having a change in the actual composition of what we're talking about. While in a chemical change, you actually do have a change in composition. How the different constituent atoms and elements match up or connect or bond to each other might be different. So my first question to you is pause this video, and we have some ice melting here, we have some propane combusting or burning here, and we have some iron rusting here. And I want you to think about which of these are physical changes and which of these are chemical changes and why. All right, now let's first think about this water, this ice melting. And if we wanted to write it in fancy chemical language or chemistry language, we could write this as H2O going from its solid form to H2O going into its liquid form. Now, we don't have a change in composition. In either state, whether you're looking at this liquid water here or whether you're looking at the solid water there, you'll see a bunch of water molecules. Each oxygen is still bonded to two hydrogens. And so you're not having a change in composition. And so this over here is a physical change. And if we kept heating that water up and it started to vaporize, that would also be a physical change. Whereas it turns into water vapor, you have your intermolecular forces being overcome, but the covalent bonds between the oxygens and the hydrogens, those aren't breaking or forming in some way. So once again, when you go from ice to water, physical change. From water to vapor, or you could say from liquid to gas, that is also going to be a physical change. One general rule of thumb when you think about what's going on a microscopic level, and this is a general rule of thumb, it doesn't always apply, and we'll think about an edge case in a little bit, is when you're overcoming intermolecular forces, that tends to be a physical change. But if you have chemical bonds forming or breaking, that would be a chemical change. Now let's think about what's going on here with the propane. If you were to write the chemical reaction here, it would be propane, C3H8 in gas form. It needs oxygen to combust. So for every mole of propane, we have 5 moles of molecular oxygen in gas form. And then when it combusts, you're going to produce 3 for every 1 mole of propane and 5 moles of molecular oxygen. You're going to produce 3 moles of carbon dioxide gas and 4 moles of water in vapor form as well. And so what you actually have is the bonds in those molecules are actually breaking and then reforming. So you don't just have physical change going on here, you have chemical change. Chemical change. One way to think about it, you had propane here before, C3H8. After the reaction, you no longer have the propane here. What you actually see as fire, which is fascinating, this is just very hot gas. And that very hot air that you're seeing, and there's going to be some carbon dioxide in there, and there's going to be some water vapor in there. The reason why it's getting so hot is because this releases a lot of energy. Now let's think about what's going on here with this iron. If I were to write this as a chemical reaction, for every 4 moles of iron in solid form plus 3 moles of molecular oxygen in gas form, and that would just be the ambient oxygen around this iron, it is going to produce 2 moles of iron oxide as a solid. And that's what you see there in the orange. That is the iron oxide. So notice this reaction is forming new ionic bonds in that ferrous oxide. And to undergo the reaction, we had to break the metallic bonds of the solid iron and the covalent bonds in the molecular oxygen. So anytime we are breaking and making these chemical bonds, we have a chemical change. Now let me give you an interesting question. What about the dissolving of sodium chloride or table salt? So you have NaCl in its solid form. When you place it into water, you get sodium chloride in aqueous form. And how does that look when this happens? Well, sodium chloride in solid form, You know it forms this lattice because they have these ionic bonds. I'll try to draw a few of them. So it looks something like this, where we've seen this multiple times. Chlorine nabs electrons, becomes chloride, becomes negative. Sodium loses electron, becomes a positive ion. And so they get attracted to each other, and then they can form this three-dimensional lattice structure when it is in solid form. And I'm trying my best to draw it in 3 dimensions over here. And actually, I could put one right over here like this. But when you dissolve it into water, the ions get split apart. You get the ions that all get dissolved, they get split apart in the water. And so the ionic bonds themselves are being broken. Now you could argue that, hey, you know, the constituent ions are just being separated, so maybe this is a physical change. Or you could say, no, ionic bonds, those are legit bonds. Those are strong bonds, and those are getting broken, and so you're also getting chemical change. And it actually turns out that this is a gray area when you're talking about dissolving a salt like this into water, whether you're talking about a physical change or you're talking about a chemical change. And actually, just this past weekend, I was at the beach and we ran out of salt, and I did it in reverse. I went to the ocean and I got a pot full of salt water, and it actually took me about 30 minutes to boil it, and I was able to evaporate all of the water out of it, and essentially the salt in that water was able to reform these ionic bonds. And so one could debate whether I was creating a physical or a chemical change. I was definitely doing a physical change with the water. I was evaporating it, but I was actually forming ionic bonds between the sodium and chloride, so one could argue that that was maybe a physical and a chemical change.